Hello class, this is Mr. Lame and I want to talk to you today about Toxins Lesson 6, which is all about the different types of chemical reactions. So we've been studying chemical reactions, we learned how to balance them, and now we're going to look at the five major types of chemical reactions that we're going to learn about in class in this lesson. So the first two we're going to talk about are, I think, two that are the most straightforward. So we have combination reactions and decomposition reactions. So in that word combination, we see the word combine. So here we're going to have two or more things combining, usually just to make one more complex chemical. So it has a general format. Chemical A will react with chemical B to produce chemical AB. So A and B were separate starting out, two separate chemicals, but they're going to come together to make one more complex chemical here. This is as simple as I can put it. On the other hand, decomposition is just the reverse process of that. So we're going to start out with a chemical that's made up of multiple elements, and that chemical, usually because of heat or some source of energy, maybe electricity, is going to decompose, it's going to break apart, split apart into two or more simpler components. And this, basically the reverse process of AB, up here, combination reaction. So we're going to take chemical AB, and in the presence usually of energy or heat or electricity, it's going to split apart, break apart into two smaller components, maybe three smaller components. So combination, two or more things coming together, linking up, combining to make a more complex chemical. Decomposition reaction, one complex chemical or two complex chemicals splitting apart into simpler components. Next two are single and double exchange. So this is where we're going to have chemicals, elements, usually switching places with each other. So in single exchange, we start out with a chemical, usually an element all by itself, represented by letter A. And then we have two or more elements that are combined, represented by BC. And what's going to happen here is usually two things will switch places here. So if A is more reactive than B, A can go in and kick out B. So then chemical B would be all by itself, and A would link up with C. So a more reactive metal could kick out and replace a less reactive metal. In a double exchange, we start out with two compounds. So we have two chemical compounds. One compound could be made up of AB. The second compound could be made up of two parts CD. And so through this reaction, once again, two chemicals, usually two elements, are going to switch places here. So if A and C switch places, A will link up with D, and C will link up with B. And then the last type of reaction that we're going to talk about is combustion reactions, because they're awesome. Alright, so combustion reactions, we're going to start out with what we usually call hydrocarbons. So something that contains carbon and hydrogens. X and Y just represent whatever number, so it could be like C3H8 or like gasoline C8H18. So any number of carbons, any number of hydrogens. We're not worried about that right now, but something that contains carbon and hydrogen will, in order to burn, combust, need to react with oxygen. And hydrocarbons, when they burn, always produce a combination of CO2 and H2O, at least the majority of the time. So that's the general formula that we're going to use to represent a combustion reaction. So let's look at some examples here. So number one, I pulled this from an old worksheet for balancing reactions. So let's not worry about balancing them. Let's just look at the reaction itself and try to classify it. So we have N2 reacting with H2 to make NH3. So besides not being balanced, we see that the nitrogens are coming together with the hydrogens. And so this is represented by chemical A, this represents chemical B. So A and B are coming together to make AB. And when that happens, that is the template for a combination reaction. We got things combining together. So A, nitrogen, plus B, hydrogen, coming together to make a more complex chemical. So this is a combination reaction. Here we start out with one chemical. This chemical, KClO3, potassium chlorate, is splitting apart. The K and Cl's are staying together, but the oxygens are going off on their own. And so this is what we call a decomposition reaction. One chemical splitting apart into two simpler components. Looking at this one here, we have fluorine all by itself and sodium linked up with chlorine to make sodium chloride. Here we see that fluorine ends up with sodium and chlorine's all by itself. And so what we see here is a switching of places. And so this is an exchange reaction. And so the F and the Cl are switching places. The Cl ends up all by itself. The F links up with Na. And so we do have elements all by themselves. Alright. So this is an exchange, and because we have elements all by themselves, it's a single exchange. If we look at this one, H2 plus O2 coming together to make water, that would be a combination reaction. Two things combining to make one. Look at a couple more quickly here. If we look at this one, very complex looking, but when it comes down to it, PB and H are switching partners. PB and H are switching partners, and so we have two chemicals here, two compounds. So this one would be a double exchange. Same thing here. We start out one compound, start out the second compound. The metals, the aluminum and the potassium, are switching places, switching partners. So the K comes over here and links up with the Br, and Al links up with the sulfate, the SO4. And so that would be another double exchange. Here we have a hydrocarbon reacting with oxygen to make CO2 and water. Same thing down here, same template. Whenever you see something made up of carbon and hydrogen reacting with oxygen, that's a red flag that you're burning something. So this is a combustion. 7 and 8 are both combustion reactions. Alright, so hopefully that helps. That is it for this tutorial.